Okay, so here's the directions that we have. Okay, we're going to take it, like I said, we're going to try to chip away and build, right? So today might be pretty easy. Tomorrow's lesson might not be as easy, but it's always a good, this acts as a very good review for what we need, okay? So, assume that every statement below is the beginning of a new proof. What information could you conclude? So, right now, they're kind of, this is shown in a given format, because you'll always, in proof writing, start with a given statement. They have to give you something in order to prove something. But usually what they do is they don't give you like these lines below. They say, hey, given this, prove this. Okay? Now in this case, if we take a look, okay, this whole system changed, but I'm going to give it a shot. If we take a look at this, we have the measure of angle 1 equals the measure of angle 2. What could we potentially apply that uses the measures of angle 1 and equals the measure of angle 2? What's another thing we could possibly call that? Think of it that way. Yeah. Congruent. So in order to prove that these are congruent, I would state angle, oh, come on now. Don't do this to me. Angle 1 is congruent to angle 2. Now, anytime we state something like that, we have to give a reason behind it. Who can tell me what the reason could be here? What do you guys think? It definitely has to have what with it, you think? Here's a C, we just said it. It's got to have something with congruency, right? Now here's the question. When we talked about congruency, did we have a theorem for it? Do we have a corollary for it? Do we have a postulate for it? No. So you would just state the reasoning is by, I don't know, why? Sorry, I'm not going to. Ooh. By the definition and unfortunately, I do need to abbreviate this because I'm using a mouse now, of congruent angles. But you guys should write it in words. So it's by the definition of congruent angles. Now, if we had congruent segments, you would say the definition of congruent segments, right? Questions on this? All right, let's take a look at number 2. So the measure of angle 1 plus the measure of angle 5 equals 90 degrees. What is that telling us? Like, what is that? Do you know? Go ahead.
That the two angles are complementary.
They're complementary, right? That's the definition of complementary. So you would state, okay, hopefully this works now. I gotta figure this out. You would state angle 1 and angle 5 are, sorry about the mess, are complementary. And obviously do a much better job than I did, right? Okay. Now that we have that, again, let's think to ourselves. We've heard about complementary angles, right? Do we have a theorem? Do we have a corollary? Do we have a postulate? No. So what do we have? Yeah.
Just the definition.
The definition. So this will be by the definition of complementary angles. Okay, now this next one, I'm going to be honest, you guys have not seen yet. It's coming though. All right, so there's no problem with introducing it early. But I'm also not going to like question you on something we haven't discussed yet. Okay? So what I'm going to do here is I'm going to just discuss what a linear pair is real quick. And a linear pair, I wonder if it won't let me write it all. Oh, a linear pair is essentially this. I'm just going to kind of draw it here. If I had two lines, or if I had a straight angle with a ray intersecting, right? So we have our three. What? Is there a question? Okay.
Maybe this is my stylus.
I don't know. No, it's not letting me do anything. I gotta call tech again. Thank you though. Appreciate it. So looking at this, what a linear pair basically states is that if you have a linear pair, they're supplementary. Okay? And if they're supplementary, they equal 180 degrees. That's what a linear pair does. Okay? So what I'm going to do is, hopefully this will at least let me erase. Hey, there we go. So I'm just going to show you this one because, like I said, we haven't really done it yet. And I'm not going to have you guys be responsible for something just yet that hasn't really been discussed. So here is this one, okay? So you have the angle 1 and angle 7 form a linear pair. Angle 1 and 7 are supplementary angles. That is what you automatically know, okay? And this is by the linear pair theorem. And I would definitely write this somewhere because the linear pair theorem, and you will not abbreviate it LPT. Remember, this is just space saving, okay? If two angles form a linear pair, then they are supplementary. And then the next thing we can conclude from that is that if the measure of angle 1 plus the measure of angle 7 equals 180 degrees, because we know they're supplementary, okay, then we know by the definition of supplementary angles. Questions on that? Again, we're gonna go over some. We're gonna definitely do the things we do know, but this sheet will act as a very nice guide for you for the things that that are coming up. So don't lose the sheet when you're done. Okay, just think of it as like your foldable a little bit. Question? Anybody still writing down 3? Okay. Give me a minute. Okay, let's take a look at number 4. Again, this is another thing we have not gone over yet, but it's coming. We may as well talk about it now, okay? So, in this case, for 4, it says angle 8 is a right angle and angle 9 is a right angle, all right? If angle 8 and angle 9 are both right angles, guess what? They are congruent to each other, okay? And that's by the right angle congruence theorem. It says all right angles are congruent. That is the idea. So instead of saying if both are right angles, then they are congruent, you can just state by the right angle congruence theorem. Now, while you guys are writing that down, I'm going to just kind of talk about these theorems and stuff like that. Now we're going to go over the theorems, we're going to go over these postulates, we're going to go over these corollaries, but if it's not one of those, it has to be a definition, and you would have to put the definition of whatever it is, okay? But here's the other thing you need to be aware of. Not everything has a name, okay? You're not going to see that today, but if it doesn't have a name, that's when you have to write down if this, then that. Does that make sense? And when I first started teaching this class, when I got here, it used to be nothing but if-thens. The names didn't matter. So it's gotten a little easier for you guys, which is nice. Okay? But if it doesn't have a name, and some don't, you have to write the if-then. Okay? All right. Anybody still writing these two down? Okay. Just checking. All right, now let's head back to the other document. So if we take a look at this, all right, we're gonna look at number 4 and 7 are complementary. So what do we know about that? If 4 and 7 are if 4 and 7 are complementary, what do we know? Go ahead. The sum equals 90 degrees. So that's what I'm going to write down here. I'm going to put I'm going to attempt to. The measure of angle 4, because remember, there is a difference between congruency and equality, right? And we're going to state plus the measure of angle 7 equals 90. And someone tell me, what's the reasoning? Go ahead, Nick.
By the definition of complementary angles.
Very good. Are there any questions so far before we continue on? Again, we're just going to keep refreshing just so that we remember some of these things, okay? How about number 6? It says angle 1 is congruent to angle 7. So what do we know? Go ahead. Okay, so we're going to state that the measure of angle 1 equals the measure of angle 7. Are you guys noticing how that transitions a little bit back and forth? Okay, and what's the reasoning? Okay. Very good. So definition of congruent angles. Remember, please write it in words. Do not abbreviate. Like I said, I'm using a mouse, so it's a mess. Oh, it doesn't follow anymore. Good Lord. Okay, what I want you guys to do now. Anybody still writing before I erase? Sorry. Okay. All right, so you guys see 7, 8, 9, 11, 12, and 13. I will give you 10. All right, because 10 we haven't really kind of talked about yet. Do everything except 10. Give it a shot, and then we'll go over it. I'm not going to call anybody out, but I want to make sure we're understanding this process a little bit. Okay? So go ahead. Is Molly here? Not yet. Okay. Oh, never mind. She's starting tomorrow. Never mind. Show of hands who's still working on these. Okay. How many sophomores do we have in here? Okay, I'm gonna have to talk to you guys after the lesson, okay? Nothing bad, nothing I can control anyway. How are we doing, guys? Any questions so far? Mm-hmm.
Correct me if I'm wrong. A vertical angle is a vertical angle. Is there anything?
No, vertical angle. Like that and that over.
Yeah, like that.
And vertical angles do have a twist that we will discuss. Yeah. I think we already discussed it a little bit, but. All right, so show of hands who's still working on these. Okay, one more minute. Okay. Okay, let's go over these a little bit. So, we did that one, okay. We did that one, okay. So, is there a little space out? What number did I start you guys with? Now all of a sudden I'm confused. We did 9, we started with 7, right? Yeah, okay, thank you. All right, 7. All right, so again, you're dealing with the measure of angle 1 plus the measure of angle 4 equals 180 degrees. So in this case, you would write in words, angle 1 and angle 4 are supplementary angles, okay? Remember, if you're not physically dealing with the measures, the M does not go in front. All right, you're not gonna put the measure of angle, you're not gonna put the measure of angle 1. You're just gonna state, hey, they're supplementary. And that's by the definition of supplementary angles. Now, vertical angles have a thing, okay? Now this one, we have angle 8 and angle 9 are vertical angles, and you know by the vertical angles theorem that they are congruent to each other. Okay? However, this is one way to say that, but there's also a definition. You could also state here, if you chose to, that these two are equal to each other by the definition of vertical angles. So the theorem states congruency. The definition states equality. Okay, and we're going to see both in the book. So again, we're just going to tell you about it now. May as well. All right, number 9, again, these are supplementary, so their measures are equal to 180. So again, there's nothing really tricky going on here, right? Number 10 is what we need to discuss. I'll come back to that. But 11 was angle 1 and angle 2 are supplementary. Same thing. I don't know why they repeated it again, just with different angles, but again, they're supplementary. Same thing. But let's talk about 10. So it says 8 and 10 are both supplementary to 7. And again, we haven't discussed this theorem yet, but I know it's coming, so we may as well discuss it now. If that's the, yeah.
My paper says they're both complementary.
On 10?
Yeah.
Oh, maybe that was a typo. Well, I mean, it's kind of the same thing, but that's okay. I can switch this out. Just give me 1 second. Sorry, didn't know that was a thing. Here. So you guys have complementary? Okay, I'm just gonna write comp here. Nothing really changes here, except now if 8 and 10 are both complementary to 7, what we assume, well, not assume, it's true. If they're both complementary to 7, like if we had like something like this, right? And this was angle 8, and this was angle, I guess it would help if I could actually like draw a 7 instead of an L. And we had a 7 here, but then we also stated like here's angle 7, right? And then angle 10 is complementary to this. We're basically saying that this and this have to be congruent to each other. Okay. So we state that angle 8 is congruent to angle 10 by the congruent complements theorem. Okay. And if two angles are complementary, just write that. Oh God, this is such a mess. I need my pen. To the same angle, then the two angles are congruent. But there is also a congruent supplements theorem. That is the same thing, except you're dealing with supplementary angles. Does that make sense? So, yes, a little different on your sheet, but same kind of context. Okay. All right, so there's one more thing I have to discuss with you guys, and like I said, the only reason I'm doing this is because you do have one problem on the test that is like this. But it's very easy, okay? So, is anybody, sorry, it's kind of a mess, but is anybody writing this down still? Okay, I am gonna clear this, just know that that's complimentary there. We need to talk about proof by contradiction. And the only thing you really need to know is that you are taking what is given to you and negating it. So remind me, what does negating mean? Go ahead. Make it a negative. Using, what word do we usually use with that? Not, right? So if I were to look at this and negate something, you're going to be given a conditional. If this, then this, right? And we're going to just negate it. Sorry, I know some people are writing, but I want to go back up to the original stuff because it looks a little bit similar to your test. But if proof by contradiction basically says, like, it can be proven because negating it gave us something false. Okay, so if I wanted to look at this one, right? given the measure of angle 1 is congruent, is equal to the measure of angle 2. All I would state here is that the measure of angle 1 is not congruent or not equal to the measure of angle 2. That's negating it, okay? They would also give you something like if x equals 12, then x squared equals 144. And all you would do with this is state, okay, well, great. You would state if x is not equal to 12, then x is not equal to 144. Does that kind of make sense? So you're always trying to find that first step and the first step is always a contradiction. Okay, so in your homework tonight, they're going to give it to you like more wordy, but it's the same kind of thing. Okay, any questions on this? What I would like you to do is this. Spend the rest of the period, okay, because I know we have the whole backside pretty much, right? All right, this is kind of bigger. Do the backside. I don't know what happened to that one there. I'll have to look at that. And we'll go over that tomorrow, okay? Now, if there's things you don't know, that's okay. I'm not asking you to turn this in, but I do want you to try it, all right? Do what you know first. We can always come back to what you don't know, okay? And we're going to go from there. And then there is a Savas for you guys too, okay? But that's all on contradiction. Any questions? All right, get going then. Those of you watching at home, have a great day.